the northernmost habitable area of Europe. So it's quite a shock to the system, and if I seem a little bit disorientated at some points in the talk, please accept my apologies in advance for that. I have no conflict of interest to declare, and the learning objectives, which I'll really follow through with in sequence during the talk, really to look about why we freeze eggs and embryos, what the impact of freezing, or cryopreservation to be more accurate, is on oocytes and embryos at different stages of development, to then revisit a thing which has already been discussed and very eloquently by Susanna this morning, and that's the importance of the concept of attrition and selection in assisted reproduction. It's really there in everything that we do. And then really pull all those things together to try and see what the options are that are available for us now in assisted reproductive technology. Maybe they've extended, maybe they're not what we assumed they were perhaps a decade ago. So I'll start with the first of those objectives, and that's to just really recap why we might want to apply cryopreservation in assisted reproductive technologies. Oops. Well, I think the first thing that we're always trying to do, and certainly when we use cryopreservation that's no different, and that's to improve our clinical outcomes. Increasingly, we're using cryopreservation in the ever-growing area of fertility preservation. It has important roles to play in a lot of the logistics of how we operate and how we run our programs nowadays. And also, of course, it brings into play a number of legal and ethical considerations, and sometimes may allow us to actually circumvent some of the problems that are associated with that. So I'll take those one by one. How do we make ART more efficient and safer in the first instance? And I think this is well established now. Cryopreservation has really been important in driving us to be able to use all the material that we generate in the stimulated IVF cycle, so to really extract the maximum pregnancy potential from a cohort of oocytes or embryos, while at the same time minimizing the risk of multiple concurrent implantations, so multiple pregnancy in essence. And of course, that has helped us to drive the field, at least in many parts of the world now, very much towards accepting single embryo transfer, and we'll hear more about that in the next talk, as being the norm, or at least the aspirational norm in ART around the world. And of course it also in some situations allows us to avoid clinical risks associated with ovarian hyperstimulation by holding off transferring any embryos. I think interestingly and probably excitingly going forward in this field, it actually might allow us, although we're still very early in this, the development of this particular approach, to make ART actually more effective and successful by avoiding the transfer of embryos into what many people would believe to be a compromised uterine environment due to exposure to very high levels of steroids as a result of ovarian stimulation. And the other side of that coin, of course, is to allow us to transfer them into a more normal uterus in a normal menstrual cycle. I think it's quite clear from the data we've seen, some of it from Australia, some of it from other parts of the world, from large data sets and national databases, that perinatal outcomes are certainly clearly now better when embryos are transferred after cryopreservation. And it's certainly not that cryopreservation improves the embryos, but it does allow them to go back into a more normal uterine environment at the time of implantation. Whether it can also result in increased success in terms of establishing a pregnancy is something that I still think that we need to wait and have solid evidence around. But it's certainly an exciting prospect going forward that may be the case. Fertility preservation is really an area that gathers apace in this day and age. Initially designed for situations which I would say were medically indicated, and that's normally in younger women who have to undergo cytotoxic therapies associated with malignant disease, and it offers them the prospect of cryopreserving oocytes, in some cases embryos, and in some cases in fact ovarian tissue, which we're not really going to discuss today, as a, if you like, a precautionary measure against the possibility that they will not be able to generate any female gametes in the future after that therapy, but may survive and wish to establish a pregnancy using their own genetic material. Increasingly and more controversially, I think we're now seeing a drive to extend that particular technology that's available into what I would call socially motivated fertility preservation, where women are now considering themselves perhaps at the age of 30 to be in imminent danger of losing the prospect of actually mothering children at some point in the future, and therefore, as a form of reproductive insurance, might wish to consider actually cryopreserving their oocytes in the event that they eventually find Mr. Right, rather than have to accept Mr. Well, I guess he's okay. Logistics can be impacted quite dramatically in situations in the ART laboratory. Certainly, increasingly now, people are managing programs of oocyte donation, and we see the emergence of more and more egg banks now by extensively applying cryopreserved oocytes in those situations. And of course, that means it's much more compatible with the concept of transport of gametes from between units from all corners of the globe. It's essential now, with the increasing drive towards trophectoderm biopsy for preimplantation diagnosis, that those embryos have to be cryopreserved pending the results, at least as things stand at the moment. So it becomes an essential part of PGD or PGS in that context. And of course it allows the quarantine of gametes pending their use, so that we can actually screen going forward for transmissible diseases. A number of legal and ethical considerations, and it's interesting in a way because we will look at how the impact on them, but a lot, of course, of the technology, particularly in oocyte cryopreservation, as one of our chair people will know very well today, was driven by legal restrictions on embryo cryopreservation that were introduced notably in Italy, but certainly also in some other countries. Increasingly, we hear about patients having concerns over the status and the fate of embryos that are left at the end of their treatment, whether or not they have actually conceived in the course of that treatment, and their ability to deal with the concept of having to either discard those embryos or find another fate for them. Relationship stability, I won't say too much about, but it's a fact of modern life, I think, in almost every society, and therefore issues associated with how couples that separate and have to deal with embryos that are left that have been generated in treatment are obviously going to be issues that have to be dealt with. And of course, in a small number of cases, but I guess like something going forward that we might have to consider more, the desire for some people to actually conceive posthumously using gametes that have been cryopreserved when someone has actually been alive. So there are a number of factors, a number of areas where cryopreservation plays a very important role. And I think I want to go back, and I guess in the mood of the debates that we're having today, to revisit old assumptions. And the historical perception, I think, was that it was because it produces inferior outcomes, we should only really be freezing eggs when we cannot freeze embryos. And therefore it's a bit of a last resort in many situations. And I think really the basis of today's talk is to ask if that's still valid. Of course, the technology associated with oocyte and embryo cryopreservation has undergone evolution. We've seen oocyte freezing go from what we would call conventional slow cooling through modifications to that particular approach onto vitrification. Cleavage stage embryos have pretty much gone down the same pathway in terms of the technology applied to them. In blastocysts, we've also seen a move from slow cooling to vitrification. So how do we assess the effectiveness of it, which of course is what we have to do first, if we're going to compare the use of one against the other? There are two key features that we have to establish, and I think sometimes people talk about survival as the be-all and end-all. I actually think the most important thing that we have to establish from any cryopreservation technology is that the function, the biological function of that material, be it an egg, an embryo, and in fact ovarian tissue, after it's been cryopreserved, is similar or preferably equivalent to what it would have been had it been used fresh. So we have to establish that, or to what extent that's true for the material we cryopreserve. And then the secondary question, if we can establish that, is what proportion of the material that we store is actually going to be available to us going forward for treatment. And the question, coming back to that again, just to emphasise it, can we actually say at this point in time that oocyte cryopreservation would be as effective as embryo cryopreservation if we were looking at what the options were in particular clinical contexts? So I'm going to start where I guess it did start, and that's with the cryopreservation of cleavage stage embryos, which was really the mainstay of many ART programs for at least 2 decades. Initial methodology, which actually after some earlier modifications by the group in France, away from DMSO-based methodology, involved slow cooling and multi-step processes using propane diol and a low 0.1 molar level of sucrose. And it was established by our own group and by the French group, importantly, that those embryos that survived intact after cryopreservation using this methodology had the same developmental and implantation potential as fresh embryos, if they survived intact, and if we compare embryos of the same morphological and any way that we can measure quality applied to that. So they had to be equivalent embryos. And that stood true in the studies that were presented there. However, what we also knew from those early studies was that anything that resulted in post-thaw blastomere loss was associated with a reduction in that implantation potential. That's just some data from a paper we published. This was made much easier to demonstrate with the advent of single embryo transfer, where you can see that while minimum loss of blastomeres from an embryo might have relatively little effect on the outcome in single embryo transfers, once that gets to beyond that stage, there's really quite a dramatic loss. So in essence, it becomes a simple equation with embryos that are frozen at early cleavage stages. It's really simply a question of survival. The proportion of embryos and the proportion of blastomeres in particular that survive determine the effectiveness of that particular technology. So how many survive, given that we've established that in equivalent embryos, fresh equals thaw in terms of developmental potential, as long as intactness is demonstrated. From a large study and also from a study in a randomized controlled trial, we can see that if we define survival by at least 50% of the blastomeres surviving, which is the conventional way of describing it, but probably inadequate, we can see that we can get survival up 80 to 90% of the embryos. However, more importantly, fully intact embryos only really comprise about half of the population that are frozen using that earlier technology. So this really has to be improved if we're going to call this an effective technology. It can be improved, and our own group spent a lot of time developing a method, a single-step protocol for dehydration of the embryos prior to slow cooling, using an increased level of sucrose as well as shortening the process significantly. And we showed that we could increase overall survival to around 95%, with around 80% of the embryos being fully intact and about 90% of them having minimal blastomere loss. So that could be achieved, but really while we were developing that, of course, vitrification appeared on the scene with a bang, and vitrification can at least match the improvements that we were able to achieve in the slow cooling protocols. And we can see that from a randomized controlled trial and a method using propane diol and ethylene glycol, and from a larger study from Ana Cobo's group in Valencia using the DMSO ethylene glycol methodology and an open system for vitrification, that again we can achieve 95% survival, but importantly, particularly in the study from the Spanish group, we can see that 90% of those embryos are fully intact after cryopreservation. So that's what we can achieve with cleavage stage embryo cryopreservation, but of course, as we've already heard this morning, most units have now moved towards predominantly culturing embryos to later stages of development. So how about cryopreservation at the blastocyst stage? Interestingly, if we go back really not much more than a decade and we look at some of the publications from the Japanese group in 2005 and a comparison of slow cooling and vitrification, while the vitrification was giving slightly higher survival, really not huge differences in terms of the effectiveness of the two technologies in that published study. Similar results reported by Liebermann and Tucker in 2006, again showing really marginal improvements with vitrification over what could be achieved by really very successful application of slow freezing to blastocysts. However, overall vitrification seems to have been adopted hands down in terms of the units around the world now, and I think maybe because in more people's hands it gives a more reproducible guarantee of success. So I think we're really looking at vitrification being hand in hand with blastocyst cryopreservation. Importantly then, we have to establish equivalence of fresh and cryopreserved material before we look at going forward. And this is a good, well-constructed study published by a Chinese group in 2012, where they actually, again, this is really important when you look at the outcome from cryopreserved versus fresh material, that you actually standardize for the quality of the embryo that you're looking at before and after. And when you do that, looking at blastocysts of different morphological quality, then you can see that the differences between fresh and vitrified, there are no significant differences. Any suggestion, of course, with the numbers included, any suggestion that that's an improvement really would need much larger studies. So we can see that vitrified blastocysts behave in terms of implantation potential at the same level as the equivalent fresh material. That's been verified in a much larger, less controlled study in a sense for that. This is data that we published from the Australia-New Zealand database. So, as is not very often the case in reproductive medicine, we're actually able to talk about almost 50,000 as an N here in this particular study. But as I say, it's not a prospective study in any way. The clinical pregnancy rate from fresh blastocyst transfers, marginally higher than that from almost 20,000 vitrified blastocyst transfers. But that's more than offset by the fact that the mean number of embryos transferred in the fresh situation was 1.3 versus 1.1 in the post-cryopreservation group, and that would more than compensate for any increase there if that really is an increase. The other thing, of course, is we have to remember that according to conventional practice, in the fresh blastocyst transfers, the best quality blastocyst will inevitably be transferred in most situations. So those transfers will, to a large extent, involve the second and third best embryos that are available in cycles. So I think when we look at the difference in numbers and the fact that the best embryos are overrepresented in this group, I think we may suggest from that there's a real good reason that we should be looking at whether we can actually achieve a better result with vitrification of blastocysts rather than transferring them fresh. Survival can be achieved at a level of 90% or above, and that's just really confirmation from a number of studies that have been published. And I just sort of keep coming back to the fact that it can also be achieved in some circumstances using slow cooling. Vitrification is not essential to be able to achieve that. However, it really has become, as I say, the conventional methodology. So moving on now to, I guess, the important part of it, and that's the cryopreservation of unfertilised oocytes. Can that really compete with what we've been able to achieve with embryos? Well, the early results really weren't that promising. Survival around, this is using a method that was similar to that that was being applied to embryos in the 90s, and it's reviewed in a paper in 2007, Human Reproduction Update. Survival really hovering around 50%, which immediately renders it somewhat unacceptable for consideration unless there was no alternative. Fertilisation rates seem to be compromised relative to fresh material, although no really good controlled studies available. And more worryingly, the developmental and implantation potential of those resultant embryos appeared to be reduced relative to those achievable with fresh oocytes. Establishing equivalence between fresh and cryopreserved material, we came some way towards that, again by applying some of the modifications that we had introduced for embryos in fact, it probably preceded the move towards using it for embryos, using higher levels of sucrose in the dehydration process. And we could see that when the transfer of, and these are early cleavage stage transfers, that fresh and cryopreserved could give similar implantation results in women in defined age groups. However, survival seemed to plateau at around 75%, so we're still not getting up to the sorts of levels that can be achieved with embryos. And then along came good old vitrification again, and suddenly that appears to be solved. And as our initial results looking at the in vitro endpoints showed that with a level of survival around 97%, that fertilisation rates, the proportion of embryos that cleave to day 2, the mean cell number, and the blastocyst development rates were similar in fresh and vitrified material. I'll just point out in the results there, they're somewhat skewed, and I think sometimes in terms of expectation. This work's all done on oocyte donors with a mean age of 27, so not your average assisted reproductive treatment patients. Oocyte vitrification, again applied now, moving on to the clinical phase of verification, shows that again achieving survival levels over 90%, with fertilization rates, embryo quality at cleavage stages, and implantation rates with the transfer of day 3 embryos being essentially identical in the fresh and frozen material. And that's again using the open vitrification system, using ethylene glycol dimethyl sulfoxide. That equivalence of fresh and cryopreserved has been confirmed by other groups in cases where blastocysts have been transferred, in the top 2, and also with cleavage stage transfer. And again, with survival levels hovering around the 90%. Just to emphasize the fact that many of those studies have been done using donor oocytes, where the oocyte cryopreservation has been applied for logistic reasons, we can see that when we apply it in a multi-center study from Laura Rienzi and others, that although the survival is still certainly respectable level, it's perhaps a little less fertilization, and now we're seeing implantation rates on the transfer of early cleavage stage embryos that are more representative of your ART patients. So I think what we can say, having looked at that for both oocytes and embryos at different developmental stages, we can put a tick in the box for all 3, in the sense that the post-cryopreservation material can match the fresh material, as long as we insist on comparing equivalent entities before and after. And that survival rates, again perhaps dependent on the population, but also within the natural variation from unit to unit, can vary between 85 and 95%. So we're really achieving now 90% survival levels of material that's as good as new. Which really brings me then to what I think is the most important consideration in determining whether we use egg freezing or embryo freezing. And that's really the thing that pervades everything that we do, the concept of selection and attrition in ART. We're all familiar, and this is very much a stylized representation of the normal expectation, that from 10 oocytes that we might have available to us, we might expect something like 7 of those to go through the fertilization normally. We might expect that at cleavage stages, day 2 or day 3, we might have anything between 3 to 5 good quality cleavage stage embryos. And if we carry on culture for an extended period, we might, from that original 10 oocytes, end up with 2 to 3 blastocysts. So what we're seeing is material which is increasingly proven itself along that pathway, so it's likely to have higher implantation potential, but of course it's also going to, on the other side of that coin, increase the number of entities that are going to be rejected from treatment because they don't actually get over the hurdles. But the thing that we have to remember, of course, while that's based on the many thousands that we'll look at in most units over the course of a long period of time, it can be highly variable between patients. So to tell a patient that you'll be guaranteed that from 10 oocytes, you'll have 2 to 3 blastocysts available would really be a very dangerous thing to do. It's based on, very clearly, on averages from large populations. So what should we store for patients? Should we be conservative and say, let's bank everything? Or should we be highly selective and potentially much more efficient by only storing material which is of proven quality? And I guess the question then is, what's the answer to that in each of the different clinical contexts that we talked about earlier? And that's where I'm going to go back now and revisit those contexts in which we apply cryopreservation. I think for ART patients, cleavage stage, and Susanna covered this extensively in her talk today, will allow us to maximize the utilization of the fertilized oocytes that we have, and it will certainly give us some information about the relative quality of that material that we've stored. So there will be some indication of what potential is in the bank. However, if we extend that to the blastocyst stage before cryopreservation, then of course the material becomes much more highly selected, and of course for a patient's perspective, and that's really important for those patients, it may well result in a reduced time to pregnancy, because the material that we're using is, while lesser in number, is higher in developmental potential. So why would we even consider the possibility for those patients of using egg freezing? And I'm not going to suggest that that's in any way on a universal basis that we might want to consider that, but I'm sure for some patients there may well be issues that they want to deal with prior to undergoing a cycle of IVF. Patients might want to remove issues around ownership that are likely to occur if embryos are left in storage. And again, if relationship stability isn't all that they might have expected. And while we might think that patients going through IVF don't really want to consider that at the time. Certainly lots of people undergoing commitment in relationships these days don't seem to have any problem about establishing prenuptial agreements around their financial affairs. So I wouldn't be surprised if this may well be still an important issue for some patients to consider. And of course that would mean that it would be flexible for use in the future, potentially if there was a new partner, if we used oocytes rather than embryos for cryopreservation. Ethical dilemmas around the disposal are certainly significantly reduced if the decision is to discard a gamete rather than what some people might see as a human being. I think that really goes without saying. It may well be that if at the end of treatments, in many cases, we have oocytes left in storage, then patients may be willing to consider donating those oocytes, where they might not be willing to consider donating an embryo, which would essentially be a sibling to any children that they have actually conceived through the treatment. And of course, in many situations, it's going to be important just because it satisfies the legal requirements of that particular regime. One thing we should always remember in that, and while we're on the process of revisiting old dogmas, cryopreserved oocytes can only be fertilised via ICSI, even when normal sperm is available. I personally believe, and I know others do as well, that that's a dogma that really does need to be revisited. And I think it's perhaps appropriate, given the editorial in Human Reproduction last week, that ICSI may not be cost neutral when we apply it when there's no necessity to apply it. So I think that's something that we've really got to think about with cryopreserved oocytes as well. Fertility preservation patients, the great advantage, of course, to turn things on its head now, oocyte cryopreservation, probably the first line. No requirement for a partner or a sperm donor, and of course that's the situation in many of those cases, particularly in all the situations basically. Future use, of course, is unrestricted. The gamete is clearly associated with the gamete donor that's had it cryopreserved, so ownership is clear. And of course anything that's cryopreserved as an oocyte may benefit from any future developments in embryo culture technology, since it hasn't actually been exposed to them at that particular point in time. So new methodologies might be available in the future in that situation. When a partner is available, and that is an option, the advantage associated with cryopreserving embryos rather than oocytes is that we can actually have some estimate of what's in there. To tell a patient they've got 10 or 20 oocytes in the bank really isn't giving them a lot of information about what the potential is there, because any estimate's going to be based on the whole population, not on that individual. Whereas if we already go down the pathway to some extent, we may well be able to have a better estimate of that. And of course that becomes much, much more accurate when we culture the embryos to the blastocyst stage. So telling a patient that they've got 3 blastocysts in storage for potential future use is very different from telling them that they've got 10 oocytes banked. And I think that when partners are available, that's a consideration that patients need to consider. In cases of oocyte donation, I think it's quite clear that oocyte cryopreservation has got advantages associated with it. We don't have to commit all the oocytes in a cycle to a single sperm source when they're fresh. We can bank them and then give consideration to that in a future date. It certainly simplifies synchrony between donors and recipients, transport's facilitated, and we can also carry out quarantine pending the testing for infectious diseases without actually creating embryos. So it does have advantages there similar to those that are available to people who bank sperm in those situations. Preimplantation genetic diagnosis, of course, the detection of both meiotic and mitotic aneuploidies that we can generate from genetic analysis of trophectoderm necessitates cryopreservation at the blastocyst stage. But interestingly, there may be some option even to classify our oocytes before cryopreservation using polar body biopsy to determine at least the meiotic aneuploidies that have occurred by that point, and therefore perhaps only cryopreserving and making available euploid oocytes. And finally, the legal ethical issues relating to the fate of unused embryos and all the other areas that I've already covered may also be simplified if oocytes rather than embryos are cryopreserved. And I think what we have to remember, it's not an all or nothing thing. It may well be that in many situations a combination of oocyte and embryo cryopreservation may be something that patients would wish to consider. And I particularly think of ART patients who generate 25 or 30 oocytes, young women who generate 25 or 30 oocytes in the course of an egg collection. What are they wanting to free? Do they want to generate potentially 25 embryos? Or do they really want to consider a mixture of these two approaches? So in conclusion, With optimal methodology, I think we've established now, with the studies of many, that we can achieve similar outcomes from egg and embryo freezing, irrespective of what stage we freeze the embryo at. Therefore, there's no longer justification to say, and I'm answering one of the earlier questions, that we must only use oocyte cryopreservation when there's no alternative available. Embryo, particularly the blastocyst cryopreservation, gives us a much more accurate prediction of what we've actually got stored. And that may be really important for some patients to actually know much more accurately what the potential of that material is. And oocyte cryopreservation on the other side of that may help to circumvent a number of logistic and ethical problems and legal problems that we may encounter in the RT in different contexts. And therefore the choice of egg or embryo freezing, I don't think it really is A or B. I think it's a very much an individualized thing, and I guess that's the tone of the symposium that we're having today. It will be based on a number of considerations and will be very different for very different couples. And thank you very much for your attention. You travel all the way across the world and all you see is buildings and boats and water.
Yes, I have to say I didn't notice any effect on the jet lag on your presentation, and I'm sure the other attendees enjoyed your talk as much as I did. So I will start with a question. And vitrification has marked a turning point in oocyte cryopreservation, and I can hardly see a way by which we can improve a 90+ survival rate. But I have the feeling from a few papers that have been published on this specific question that there is an attrition there after fertilization, which is more or less comparable to fresh. In other words, when you culture embryos from cryopreserved oocytes after fertilization, you have some loss, which should be taken into account. Would you like to comment on that?
Yeah, I mean, I think it's an interesting calculation that you will lose some, but you will also lose some embryos further down the line. So blastocyst cryopreservation doesn't achieve 100%. So to have 90% survival of oocytes versus 90% survival of blastocysts is an interesting mathematical situation to try to model. Because when you lose a blastocyst, you lose something of far greater value potentially, but it's much more broke. Whereas if you lose an oocyte, you don't really know what you've lost at that point in time. Is it the one that would have produced the blastocyst or not? So I think that requires probably mathematical model. Perhaps the idea is really to do, as people keep saying today, a proper randomized controlled trial for that, and then look at cumulative outcomes. But cumulative outcomes are interesting for so many reasons. For a start, most cumulative outcomes never use a lot of the material that's generated. And so it's, in a sense, it's a practical definition rather than a real scientific biological definition.
Yes, but I think entirely right in terms of comparison. But my reflection was the fact that there may be some room for improvement in oocyte cryopreservation still.
Yeah, I think that may well be true. I think we have to ask, once you've achieved 90% to 95%, why do the 5 to 10% not survive? Can they be captured as well? Can we actually achieve the panacea, if you like, the 100%?
Yeah, even the development post-fertilization, even given the same survival rate, you may try to work and improve further development after fertilization. That's what I meant.
In what kind of approach, Giovanni?
That would be an objective. No, I don't know the approach.
I think the fact that the development appears to be the same from the embryos generated from cryopreserved oocytes and fresh oocytes would suggest that that's not a biological issue. Those oocytes that survive are expressing their inherent biological potential. That hasn't been affected by cryopreservation. So it probably really is just an issue of, can you get a higher proportion to survive?
Thank you, David. Very nice talk, as usual. So, I'm understanding correctly that you think outcomes with fresh and vitrified warmed oocytes at this point are equivalent?
I think
Is that
under
fair?
optimal conditions they are, and I guess that's all we can say. It is being achieved. Whether it's reproducibly achievable from unit to unit is a completely different question.
Exactly.
And I think
Exactly.
that is, but I think that the proof of principle in these situations is
Right.
actually important. Under optimal conditions with optimal biological material, and that's why I stress the use of 25, 27-year-old fertile egg donors,
Right.
can be really probably as good as it's likely to get. And Giovanni may be right, but maybe even to achieve slightly better than that. That can be achieved. Whether the lack of achieving of that is due to the biological material being inferior or the application of the technology, but that's then a question of or technical standards within laboratories.
Right. No, I think the point is well made. I just out of interest, I would mention that I looked at the 2014 SART data, and this is the first year they made the oocyte cryopreservation warming data available, actually, to be able to separate fresh versus frozen eggs. And on the national level, there is no question that in oocyte donation, results are significantly better with fresh eggs than they are with frozen eggs, and that if you look at individual centers, that it seems that in every center I looked at, and I looked at quite a few, I have not done a full study, but looking at a few centers that I checked, in a majority they were doing much better with fresh eggs compared to frozen eggs, with the exception of those centers that have their own egg banks. And in those centers, either they were not doing enough fresh oocytes to make the comparison, or if they were equivalent.
Yeah.
So very interesting, and
Yeah.
along the lines that you were
I think we're
mentioning.
talking about the relative technical application then
Right.
from centre to centre. I think that's the only explanation. I mean, certainly the studies from the Spanish group are performed in large numbers of oocytes, and they have a very specialised, Maria's here, I think, anyway, isn't she? I mean, you have a very specialised approach to this. This is a major part of what you do.
Right.
There has been a huge focus in Anna's group on the technical standards that have been applied to achieve those results. So I think maybe what we have to ask ourselves is, why can't those be achieved on a more reproducible basis? It's exactly the same with why we're using blastocyst vitrification when people in the past had achieved identical results with slow freezing, but not enough groups could. I'm sure slow freezing can actually achieve the results that vitrification can, but people struggled and then an easy option was given.
Yeah, we are very happy with egg banking, although it's not simple to make a stock of oocytes.
It's a lot of resources as well.
A lot of work and
Yeah,
resources,
yeah.
human resources, physical resources, economical resources. But still we are struggling sometimes with eggs from young women that do not survive after cryopreservation. We don't have any insight of what is the reason why certain women, certain egg donors create oocytes that not survive after cryopreservation at all. So, and it happened. I mean, even though the average of survival rate is very high, we still have some cases with no survival.
I mean, to me, the surprising thing is, and we've discussed this in many publications, is that it's as good as it is. Because we expect to apply a single methodology to biological entities such as oocytes that have huge differences in the hydraulic permeability in terms of water transport across the membranes.
Well, we pay attention.
But you use more uniform times.
Well, we try to see the oocytes when.
Yeah, there's a level of individualization in
Yeah.
it, but it can only be to a certain extent for practical reasons.
Yeah.
And I think that's the same, because I think it was raised this morning. Does every embryo find the same culture conditions optimal? It would be surprising if they did.
Yeah, right.
And I think it would be surprising if every oocyte responded optimally to exactly the same methodology for vitrification or slow freezing.
Well, since I'm here, I just want to make a comment regarding oocyte cryopreservation versus embryo cryopreservation. We have seen some patients that we decided to go for oocyte cryopreservation, and after doing some accumulation of oocytes, we discovered that the embryo quality was awful. And then we said, well, maybe it was worth it to do oocyte cryopreservation, and because if we have done ICSI from the very beginning, and we can see whether this patient is able to create good embryos or not. You know what I mean? I mean, sometimes you think that oocytes are good enough, and then you discover in the lab that the oocyte quality, the embryo quality of this woman are terrible, and it's like you sometimes lose time. You need to know sometimes in certain patients the embryo quality, and not to wait until.
Yeah, of course. No. And I think that was what I was saying.
Sure. Thank you very much.
Greta Verheyen from Brussels, Belgium. Hello. David, thanks for the nice presentation. I have a question on the selection of oocytes before vitrification, because we know that for embryos the success rates highly depend on the selection of the embryos that you vitrify. Yeah? And there are differences in criteria between centers, but if you look carefully into papers, sometimes you see that not all metaphase 2 oocytes are vitrified. I wonder how the oocytes for vitrification are selected. Do you freeze all the metaphase 2 ones, or just exceptionally exclude those which are looking really bad? Or?
That's a really good question. I mean, I think with oocytes it's a different question. I don't necessarily accept the premise that poorer quality embryos have much poorer. There might be a marginal effect there, because I think that survival is much more to do with the membrane characteristics rather than the viability characteristics of embryos. So if you freeze a bad quality embryo, you'll get a bad quality result at the end of it, but it won't necessarily affect the survival.
No, but
so
it will affect
poor quality in, poor
rate.
quality out.
Yeah.
But I think that with oocytes that might be different, because the characteristics are probably. What you're asking me is actually just indicative of the same sort of thing that we were discussing with Mina. You're asking me what we do. We freeze all our metaphase 2 oocytes, but most of our patients who are having oocytes cryopreserved are only going to have one bite at that. They're patients with malignant disease who are only going to be able to freeze their embryos in once. So we just take the conservative approach. You can do no damage by that other than raise expectations in those situations. So we do that. I don't know that that is the same criterion or criteria, depending on whether you've got additional ones, that other groups would apply in the same circumstances. Other people, and Giovanni might comment, with more experience, having applied that in ART, are you selective about the oocytes that you actually cryopreserve? If you're dubious about their quality, do you leave them out from that pool? And that may be a different equation than those who are using them as donated material, where they want to guarantee a minimum quality for the patients after that as well, for the recipients. So I think that might vary. In our situation I'm answering, but I don't know that that's typical.
Yep. Okay, thank you.
So then last question.
Thank you, David. Shanti from Copenhagen. It's just more of a comment, because I mean, for many years we've been freezing embryos sort of from the perspective of this is surplus material from a stimulation cycle, and how do we preserve this the best. But now that we're moving towards cryopreservation oocytes with much more long-term possibilities, maybe we are sort of trapped in the same mental dogma from the embryos. I mean, we have data now suggesting also from young oocyte donors that only 5% of the oocyte works. That only in 1 out of 3 cycles there are oocytes that can actually produce a baby. So maybe we sort of mentally should rethink this. Should we stimulate several times before we for cryopreservation of oocytes or other things? I mean, I just want to caution that we don't think it in the same box as we did with how to restore the surplus embryos.
I agree. We have to be flexible.
Okay, well, thank you very much, David, and all the discussion triggered.